Welcome to this video on the basics of matter and minerals. I'm Aida Awad from Broward College. For this video, we'll be talking about three learning targets. The first being defining a mineral and classifying objects as minerals or nonminerals. The second, identifying physical properties of minerals. And the third, identifying chemical properties of minerals. The definition of a mineral has 5 different pieces. First of all, minerals are naturally occurring. Secondly, minerals have set chemical compositions. Third, minerals are inorganic. Fourth, minerals are solids. And fifth, minerals have a set crystal structure internally. So for example, we could talk about ice. Ice is naturally occurring. It has a set chemical composition. It's inorganic. It's a solid, and it has a set internal structure. So ice would be classified as a mineral. How about a pearl? What do you think? There's one of those characteristics that it doesn't meet. Which one is it? Moving on to talking about the physical properties. We use physical properties of minerals to diagnose them and to determine which mineral is present. One of those physical properties is color. As you can see in these two diagrams here, a mineral named fluorite and a mineral named bornite have the same colors in this case, and they have many different colors. So in general, mineral color is not a good diagnostic property because many minerals have the same color, and within one mineral, there may be different colors present. When we're trying to identify a mineral, we move on to things like the mineral luster. Mineral luster is the way the mineral surface reflects light. And there are 2 main categories of mineral lusters. They are metallic and non-metallic. Within the non-metallic category, we break it down into waxy, pearly, earthy, glassy or vitreous, dull, resinous or plastic, silky or fibrous. So you should be able to use the pictures shown on this page to help you identify the different mineral lusters. Next, we have mineral streak. The streak of a mineral is the mineral in the powdered form. We do a streak test in lab by using an unglazed porcelain plate, and we rub the mineral against that plate, leaving behind the powdered form of the mineral. And as you can see here, sometimes the powdered form of the mineral, like malachite on the far left, is the same green color as the mineral itself. But other times, a mineral like hematite, the second from the left, which has a reddish-brown streak in powdered form, could be a completely different color. So mineral streak is the powdered form of the mineral. Next is mineral hardness. Mineral hardness represents the resistance of the mineral to scratching. Now on the right-hand side, you see numbers 1 talc through 10 diamond. That's Mohs hardness scale, and that's the standard scale for mineral hardness. But you don't always have those minerals with you when you're trying to test the hardness of a mineral. So we can use very common objects, such as your fingernail. So your fingernail typically has a hardness of about 2.5. In other words, your fingernail would be able to scratch gypsum with a hardness of 2, but would be scratched by calcite with a hardness of 3. A penny has a hardness of about 3.5, glass about 5.5, and a steel knife or nail about 7. So we can use those objects in the lab to test the mineral hardness, but we can also scratch minerals against each other to determine which is harder. Moving on to mineral cleavage. Mineral cleavage is associated also with mineral fracture. So when you're looking for cleavage, you're looking for ways that the mineral tends to break along planes of weakness in the structure. And you can see cleavage in one direction here where the mineral peels off in sheets. That's typical of muscovite, biotite, the micas. You can see an example of cleavage in 2 directions at 90 degrees to one another in feldspar. You can see an example of mineral cleavage in 3 directions at 90 degrees to one another in the mineral halite or rock salt. And a second example of a mineral with 3 directions of cleavage where they're not at 90 degrees in the mineral calcite. Also shown on the right is the mineral fluorite, which breaks into octahedral crystals, so 4 cleavage planes. And the best way to test for mineral cleavage in the lab is simply to compare the mineral specimens with a drawing such as the drawing you see here on the slide. Minerals that don't exhibit cleavage would exhibit fracture. In other words, they break in a more random pattern, or sometimes they break in a pattern like the quartz on the left picture here, which is a conchoidal or a shell-like shaped pattern. This is mineral fracture and not mineral cleavage in these specimens. Crystal habit can also help us to diagnose which mineral we're looking at. For example, on the right-hand side, you see dodecahedra of garnet, very characteristic of garnet crystals. And on the left-hand side, you see that 8-sided double pyramid of fluorite, also very characteristic. So when you're trying to identify a crystal, if you see these shapes, it's diagnostic of particular mineral types. Reaction to hydrochloric acid is another factor that helps us, particularly when we're identifying the carbonate minerals. Now, the carbonate minerals react to hydrochloric acid by fizzing or bubbling because they're actually being dissolved by the hydrochloric acid as they release a little bit of carbon dioxide. Smell and taste can help us be characteristic, but remember to be careful of this and only use smell or taste if your instructor directs you to do so. On the right side here, you see beautiful yellow crystals of sulfur, and if you scratch those slightly, you'll get that rotten egg smell. On the left side, you see beautiful white crystals of rock salt, and if you were directed to taste that, you would taste a very salty taste in the lab. And finally, specific gravity. If you pick up a mineral specimen, does it feel about as heavy as you would expect it to feel? Is it heavier or is it lighter? In some cases, like the case of this gold or in the case of maybe barite, specific gravities can help us to determine what the mineral is. So if you would like more practice with physical properties of minerals, then you can go to the link shown on this slide. There are some example activities there for you, some questions and some pictures of different minerals. Take a look at those and practice them. Thanks very much. See you in another video.